Welcome to Lesson 7 in the Mr. Circuit Lab 3 on digital logic gates. In this lesson, you will learn about the XOR Digital Logic Gate. An XOR Digital Logic Gate can have as many inputs as needed. The one we will explain has two inputs, and therefore there are four possible combinations of input states as shown in the truth table. The first possible input combination is a 0 on input A and a 0 on input B. The second is 0, 1. The third is 1, 0. And the fourth is 1, 1. Remember that a 0 means a false and a 1 means a true. On an XOR logic gate with only two inputs, if either input but not both inputs are true, the output will be true. Otherwise, the output will be false. The general rule for an XOR digital logic gate is stated as follows. The output of an XOR digital logic gate is true if either but not all of the inputs are true. Here is the symbol for a two-input XOR digital logic gate. Look at it carefully. The symbol has a curved top and bottom with a point on the right side. And it has two inputs A and B on the left side and one output Q on the right. It also has a curved line cutting across the two input lines. You can remember this symbol by saying that the curved line on the two input lines means but not both. Building an electronic XOR logic gate. Here is a schematic diagram for an electronic XOR digital logic gate. In this Mr. Circuit Digital Logic Gate Lab, as part of your training, you will construct this circuit on a solderless circuit board. Let me explain this ingenious circuit. You will notice that this circuit has 5 transistors, 1 LED, 6 resistors, a 9-volt battery, and 2 normally open push-button switches. In this XOR digital logic gate circuit, the engineer designed it so that the LED will light up only when one switch or the other is pressed, but not when both are pressed at the same time. Let's talk about the transistors. Remember that when a transistor is forward biased, it means that it has the correct voltages on the pins to allow the electron current to flow through it. So, when you press switch S1, you forward bias transistor Q4. When Q4 is forward biased, the LED will light up, showing a true on the output. You also forward bias Q1, but you will notice that Q1 cannot conduct any current unless Q2 is also forward biased. So the net effect is that the LED will light up when you press switch S1. Likewise, when you press switch S2, the LED will light up because you are forward biasing Q5, allowing current to flow through Q5 and Q3 to light up the LED. But if you press both switch S1 and S2 simultaneously, you will forward bias Q1 and Q2, which causes a short circuit through resistor R6, and there is no current left to light up the LED. By pressing switches S1 and S2 simultaneously, you have put the same polarity on both sides of the LED, and since the LED has no voltage drop across it, the LED is unable to light up. Now that you understand how this electronic circuit for an XOR digital logic gate works, you're ready to build one as part of your training, following the step-by-step instructions in the Lesson 7 booklet. Understanding these logic gate concepts will open up your opportunities into the fields of digital design and maintenance. When you complete this lab, you will be eligible to receive your certificate of electronics training that you can display and add to your resume. If you need the Mr. Circuit Lab 3, go to www.mrcircuittechnology.com. Thank you from all of us here at Mr. Circuit Technology Company for using the Mr. Circuit Labs to learn electronics to further your career.